Welcome back, everybody. In the last video, we managed to open up the battle screen and receive our response. Remember, we had to use some multi-threading to jump from one thread to another. Let's see. As you can see, we were sending a blacklisted, a blacklisted player object because we had some recursive issues from player to socket to player to socket. It does correctly send the character, the big cool mechanic, with its health and also its skills, with the name, description, etc. Now, all we need to do is actually just, when opening the battle screen, open battle screen, we're going to have to populate our data, so the health and mana, and also we're going to have to instantiate the skills and populate them under its parent. So after opening the battle screen, we have the response, which is a socket.io response. We're going to need a JObject of the outer data, which is JObject parse, no, not text, get the value, cast it to a JObject to string. Now we have parsed the response. Now we can play around with it. Now remember, this is about perspectives, the left player and the right player. Both players will see a left player and a right player, and this code that we're going to use, that we're going to code, left is left, right is right for both players. So let's just extract it real quick. Left data, JObject parse outer data, get value left, value to string. I wonder if this is not, we parse outer data, get, no, we don't need to do this anymore because outer data is already a JObject. It is not a socket.io response, so this is wrong. We already have outer data. All I need is access the left, get its value of type string. Now, yes, exactly, right data. Now, we have the left and right data, and let's populate the health, which is fill amount, which is, well, we're going to need to left data, I'm going to get the character, health, divided by 100. What's the problem? Cannot be JToken. We're going to need to cast this to a float. Boom. Now, we could have parsed this better, but yeah, we could have parsed this with, remember, our types, but I didn't want to make more types and make you copy paste stuff. I'm now showing you how you can just directly access the fields that you know will exist. There is one problem with this, though. It's that if you somehow remove this field from the backend's response, it's going to crash. So you're going to have to handle this too. And JObject has a way to first check if it's a null or undefined, but that is so verbose. Let's, for simplicity's sake, just continue like this. Fill amount, which is exactly an MP2 mana. Yes. Now, the left and right character, so P1 character, is an image. So we're going to have to load up that image, not resources load, but remember, I made a public function to get its texture. There we go. So it's a coroutine. So we're going to do a start coroutine. Start coroutine. Game manager instance get the texture. And left data character face pick. Well, it's not the face pick. It's called image URL, if I remember correctly. Let's see. Well, this is ugly, so let's just copy this and then go to DevTools Advanced. It's the JSON here, and let's see what's happening. The format copied from Unity is not right. So let's see, can I do this? JSON is invalid. Right. Anyway, character P1, character, skills, name, magic staff. I forgot literally what I was doing. Get texture. Yeah, what was the image URL called? Was it called image URL? So let's see. Image URL, there we go. So data, well, I don't know. Sometimes, well, most of the, well, sometimes Copilot is just plain wrong. Character, image, URL. We're going to do a toString, and then we're going to have to pass in the image object itself. So like that, all right. And I think it should also perfect. Now, oh, okay. That is interesting. Copilot is pretty smart. It's already telling me that you're going to have to destroy. So this is a convention. What if we call start battle many, many times? If we don't do this, this is cleaning up the skill roster parent of its skills so that if we keep starting a battle, like reconnecting, it doesn't append each skill newly. Just remove everything in there, just clean it up, and then apply it. Let's just move that up here. So it's smart anyway. Now we have to extract the skills. So JArray, we need an array of skills instead of an object. Skills, parse, character skills. Well, I can do this easier. Just cast it to JArray, left data, character skills, boom. Now, we only need our skills. We don't need the right parent's skills. So the thing is, what is interesting here is, for us, the left player, we do have access to right data character skills. So I could inspect my network and see the enemy's skills and how much and at what remaining cooldown a skill is, for example. That is cheating. So usually you would just, in the blacklist, maybe you could make a specific blacklist for player 1 yourself and another blacklist for player 2 where it also removes the skill data before sending it to the left player, to player 1, for safety. So let's go back. Now, we don't need the right data skills, so we have the skills, and we're going to perform a loop. And for each skill, we're going to instantiate each skill. Skills count. I always forget, is it like this or without? No, it's without. There we go, I++. Extract the actual skill from it. So skill, cast it to JObject, then skills I, and now we can put, all right. Instantiate it first so we can fetch the skill script from it and populate everything it needs. Skill object, instantiate, there it is. I wasn't even looking at my screen. Left skill, well, skill container, skill prefab. Yes, so now skill object, get component, the skill. Then we have we didn't even, well, we don't need that. Just to show it, int ID, int skill ID, yeah, perfect. Then this description text, so skill name, text, I think it's name, yes, and then description, that's perfect. Then the mana cost, okay, mana cost, and then cooldown, perfect. Now the skill slot position, which is skill object get component. We're gonna have to, well, it's not remaining cooldown, it's skills. Oh, we didn't even make that. Okay, well, it needs to field skill slot position, so that's the thing we're going to send along. Skill slot position equals the index of our loop. Oh, and we have to populate the image. So there's going to be another start coroutine, game manager instance, get texture. There we go. Skill image URL, skill object get component, skills. Is it called skill pick? Oh, all right, great. I think that should be enough. Now let's go back to Unity. Are we still in? Yeah, okay, hold on. Let me build it so we can always just. Oh man, I really miss these build completed in 12 seconds. When you're making an actual game, the build takes so much longer. The Legend 27. Search game with the wizard. You're a wizard. Let's see. I'm gonna pick the big cool mechanic. Search game. Oh, beautiful. Oh, there we go. Woo. Nice. So that's me, that's the opponent. Our starting health and mana are now fixed. And we have our skills with its mana costs and cooldowns and whatever it does. Magic Staff, Energy Ball, Poison Knife, the description. Okay. Now, next step is actually sending our turn. So let's see. Send our turn. Where did I put the send turn? I think it's in socket, right? Because we're doing, there we go. Skill slot. Wait, what is going on here? So I have to send the turn, and that send turn is going to live on my skill itself. Let's just remove this. Remove that. Public void cast the skill. And we will be calling socket manager instance send turn with my skill slot position, which we populated during instantiation. So the cast skill, now we have to go back into Unity. We have to assign that behavior in the button. And we're giving the entire skill button. So open up the prefab, the skill itself will have a button. And that button will trigger my skill cast skill. Done. Auto saves the prefab. Now that will socket emit send turn object. Let's see, send turn. We have to, there we go, send turn data. How do we handle it here? We created an object. Let's see. We create an object. Do we need a special object for that? Let's just code along and just see what happens. So I have my data, but I need to trigger the do turn on my battle object. But what is my battle object? I'm not going to pass around this battle object into the front end so I can pass it back. We have to track this somehow. We could store it in the battle player, maybe? So we create the battle, but that's not going to work because I would have to first create the battle and then add it in here, but it doesn't exist yet, so that's not going to work. It's a paradox. So I would have to store the battle somehow different. I'm going to have to somehow associate all of that. So the only data I have here is my own socket and the data I send. I don't want to identify my battle through a data that I sent because that makes it hackable. I could send my user ID with a JWT token, but I already have access to the socket, and I would like to actually, let's make a set. It's a collection, basically like a C# dictionary, where I can associate my socket object with my battle object so that I can always access it. And I'd rather do it this way, so socket to battle, and it will be a simple collection, a set, like a dictionary, that I can access everywhere. And maybe in the future I will ever need that variable. So let's not send some identifiable data. Maybe I was thinking of send a JWT and then extract my ID from it, and then from the ID go through all active battles and find myself. No, I don't like that. Let's just store an association. Actually, it's not a set, it's going to be a map. Yeah, I remember, map. So in my battle manager, I'm going to store in the battle manager, export let, so it's just a variable declaration, socket to battle set equals a new map. There we go, a new map with a key value like C# dictionary. So, it says it here, map. Does it? What it is? Map constructor. Okay. Anyway, you input a socket, and for each socket you have a battle, not a battle player, a battle. Now, we can actually just set it here after we have created, instantiated the battle. So socket to battle set the player socket battle, and then the opponent socket battle. Don't confuse it. We have player 1, player 2, but we also have the player that just entered and his opponent. All right, so we should be able to, we have it exported, so we can just do get my battle from the socket to battle set. Hitting tab will populate it here, import it here. Get by socket. So now there is, this is kind of a mistake if you're making a complex game, because what we did here is, it's not fully a mistake. This is okay, but we are assuming the socket is going to stay the same. What if you make a reconnection mechanism? So you reconnect. Upon reconnection, it finds your socket, your previous socket. Well, no, it finds your socket and re-emits your battle state. Now, in this case, we did a start battle, but we can also call this send battle state, because we're going to have to reuse this based on that socket. So player 1 socket. But what if you, let's say you have issues with your computer. Let's say you're playing League of Legends. You have issues with your computer. You log off. You log in on another computer with the same account. That just created a new socket connection. Even just closing the client and reopening it instead of reconnecting, it creates a new socket. So you would have to make a reconnect mechanism where first, after you have created your socket, it stores it in a cache called my previous socket. Then upon reconnection, if your reconnection socket is different than the previous socket, swap them. Now your new socket is a previous socket. Now, this way, let's say you don't do that, it's gonna send with a new socket trying to find the battle associated with the new socket, but we never associated that. We never swapped our new socket with our previous socket. So these are things you have to keep in mind to handle. And this is not something you make the first time on your version 1 of your game. You're gonna release a minimum viable product, people are gonna play your game, they'll find bugs and inconsistencies and issues, and you're gonna slowly add all these new functions. So in this case, we're gonna keep it simple. We're gonna assume it's always the same. So my battle do turn data. Let me think. You trigger do turn on the battle, but whose turn is it? I'm gonna also, let's just do this real quick. We have a do turn. I want to send in my socket itself too. Socket turn data. Actually, let's be clean. Let's make a turn data, type of turn data. And literally all it needs is, all it needs is my skill slot, type number. So we're going to send in my socket so we know which socket to emit to at the end eventually, and the data. The data. I wonder if I can just do this to turn data. Well, it doesn't exist because I haven't exported it yet. Export. Let's hover over it, quick fix, update import. Perfect. Now the do turn. I have to identify. Oh, what just happened here? Square has no export on return. Oh, I think I saved it too fast without actually making it exportable. Let's make it. Let's see if it works. All right. Now, where were we? Do turn. So I'm also passing my own socket, so I know who am I and who is my opponent, because we have inside of my own battle, so it's a specific battle, I have to associate my socket with, hey, is the socket of player 1 or player 2? What we can do is me equals my socket. Oh, yeah, this is it. And now opponent constant. Oh, perfect. There we go. It's reading my mind. So for the people who don't know this is a ternary operator. It's just a fancy way of writing if statements. Well, it's not very fancy. It's just, it has its features. So what this does is, this is a check. If it's true, return this. If it's not true, return that. So is my socket the player 1 socket? If yes, then I am player 1. If not, then I am player 2. The opponent, the opponent, if my socket is that, but actually I think we could simplify this even further. But let's not bother with that. This is not math. So we now know in the end we are going to me.socket.emit, let's just say turn result, and we are going to be sending the same. Oh, sometimes this is messing with me so bad. Oh, beautiful. This is it. And then why is it so? And then for the opponent, does it understand it has to do for the opponent too? Yep. There we go. Let's see. Now, at this part, we have to cast our skills. Do the turn logic here. Cast skills. Deduct mana, set cooldown, all that type of stuff. But first, we are gonna have to check. So, okay, let's say you're in the battle and you click on a skill and it sends return. We first have to check if we can cast the skill at all. So the checks are, hey, do I have enough mana? Is it off the cooldown? Am I stunned or not? Or is the enemy invulnerable? These are a lot of checks, advanced checks that, well, not advanced, it's just very important to do them. And you might think, why are you doing that? The front end, Unity, will also gray out a skill if you cannot use it. But the front end should not be trusted. You have to validate all the inputs and outputs. So usually, if a skill is on cooldown, it will say, hey, there are 2 turns left, you cannot click it. Or if you don't have enough mana, you cannot click it. Or if you're stunned, you cannot click it. If the enemy is invulnerable to the skills, you cannot click it. But what if I literally go to my game manager, well, in this case, I have the editor open and I can just edit the memory. But if I pull up Cheat Engine, I can remove the status of me being stunned, etc. And I can turn it from being grayed out and disabled to making it clickable. So then I press the send turn. That's why the do turn also has to validate everything. So usually the way you would do that is player one. So let's see, me character mana. Well, no. Mana. Why is it doing like that? Wait a minute. Hold on. We of course have to grab the skill that we're using. So skill to use me.character.skills terminate a skill slot. Okay. So check if yeah, that, and check if, yeah, exactly. I wonder if Copilot does this for us. No, it's a lazy piece of. So character mana. So we can the way you could do this is if the mana amount is this, then you could make a condition like, hey, send error message to client. Or in Strapi, you can make a field for a user saying, hey, this guy is hacking, and turn it to true and then investigate. So you could do a lot of stuff with this. For now, we're not going to spend time making these checks. You understand it's very easy to do these checks, but we want to keep this course short. It's already pretty long for a basic proof of concept. Now, we have skills to use. This is some checking if it's undefined. Well, that's not going to be undefined in this case. We're going to have to cast the skill. Now, here comes one of my favorite parts. Let's do this real quick. Me character mana deduct, and then me character cooldown. Remaining. Interesting. So I haven't made the remaining cooldown variable on the character. So what's gonna happen is remaining cooldown equals skill to use cooldown, and then every turn there will be not a cron job, just every time the do turn happens at the start, it goes through all the characters in the game in the battle and deducts one remaining cooldown. So that's just the turn processor. But we're not going to do that. Now, this deducting mana is enough. Now, this implies that we have cast a skill here. Now, here comes my favorite part. How are we going to cast a skill? How does it even work? Cast a skill on opponent. That's going to be a topic on itself. I'm going to end the video here. So the next video, we will be making the actual casting the skill logic. So what that does is it looks at what the skill is supposed to do. So all we have done so far is the skill has a description, as in this skill deals 15 magic damage to one enemy. First, we're going to have to make the damage behavior on an opponent. Just like how you're going to code a single-player game in C# Unity, you will have a player class. So that's, in this case, the character. So let's just me.character. And that character will have some take damage function, and you pass in an amount. The dilemma here is we don't have the take damage function on the type character plane because these types are generated. And now we cannot go in here and make a function here for taking damage because this is generated. Now, we're going to end this here, and in the next video, I'm going to explain how to tackle this, and we can beautifully fix this in a very neat way. So, yeah, I'm stopping the video here. I'll see you in the next video.